If we select the skirt element and go to the tab General Input, we can see the values matching with the final input of the skirt element. For example, the thickness of 8 mm. We can also see that the internal pressure is 0. The reason for that is that the skirt is not a pressurized element. Instead, it only carries the vessel. If we move to the next element, either by using the arrows up top or by clicking it in the 3D viewer, we can see that we do have an internal pressure here. We can change this internal pressure, for example increasing it to 10 bar, and PV Elite will design the vessel for this 10 bar. We see in the design constraints that the design pressure of the vessel as a whole, however, is still 6 bar. Also, the pressures of the other elements stay at the 6 bar. If instead we would change the pressure in the design constraints, a pop-up appears from PV Elite, which asks whether we would like to update the model to reflect the change. If we click yes, all of the elements now have a design pressure of 10 bar, apart from, of course, the skirt, where the 10 bar is inputted, but it doesn't have any effect. If we open up the results file, we see many different reports. We will now go through these one by one to have a look at what information is actually in there. The first real report about the model is the vessel design summary. It gives an overview of the specifications for the vessel, like the design temperature and the MAWP, which is the maximum allowable working pressure. The maximum allowable working pressure always needs to be higher than the pressure and then the design pressure, or at least the same value. If the element maximum allowable working pressure is much higher than the design pressure, for example for the sump head, it often means that the element is slightly over-designed. MDMT stands for the minimum design metal temperature. When metal gets very cold, it becomes brittle and can handle less loads. The MDMT summary gives warnings as to which parts might become colder than allowed for the material. The basic minimal design metal temperature can be reduced if loads are low enough. This is why the report shows both a basic MDMT and a reduced MDMT. Since the required minimum design temperature for this model was -30, it is acceptable. The next report is the warnings and errors report. We can see that it is orange, which means that there is a warning in there. When a design fails, the internal pressure calculation summary is often convenient to find which element has the problem, and then you can go to the correct report to find the actual problem. Then the code-based calculations for all of the elements are outputted. If we look, for example, at cylinder 1, we see the input information for cylinder 1, and then as a first calculation we see the well-known calculation to determine the required thickness based on a pressure for a cylinder. All in all, this vessel passes all of the checks and is acceptable according to the code. That wraps up the exercise.